Can you? Yeah, yeah, lots of echoes. Oh my God. Okay, how about now? Do you hear me now? Better now? Okay, perfect. Okay. Unfortunately, it's from a different device. This is okay. Not sorry. This is very can't continue like this. Okay. Well, I'm glad it's better now. All right. Well, it's coming through the. It's not coming through my computer, so I don't know what that says. All right. And wait, this means I can't hear you though. Wait a sec. Okay. Wait, could someone try to talk for a second? Let me just see. Can you talk?
Hello, can you hear me?
Oh, okay. I guess I can. But this, all right. Thank you. I mean, this is all coming through my whiteboard, which is not ideal, but not your fault. I mean, and hopefully not even your problem. Hopefully this will be fine for you guys. This is very strange on my end. Um, okay. Well, anyway, all right. Let's just get going. All right. I'm sorry. This is, as you know, I didn't have my computer last week. I've got this is not interesting, but I have my computer back now, but apparently that aspect of it was not. How could that be? All right. Anyway, all right. Let's just get going. Okay. Um, so I apologize. We'll just get going. I think we know where we are. We're starting to catch up with ourselves. Um, if you, I'm glad it's better now. Or I'm looking at the chat. We are recording and all of that. Even though we had all these technical difficulties last week, hopefully you saw that a recording of last class was eventually posted. I don't know how good a recording it was, but it is there. Let me know if it's worthwhile at all. As you also know, the homework 4 is not due today. It's due Wednesday. We have a lot, but then you're gonna have a break because I know we're like nowhere near. Yeah, let's move on with the homework solutions. Yes, we're gonna. Okay, we're moving on with the homework solutions. Okay, I just want to make clear that whatever points you got, as long as you did train of thought and did it thoughtfully, even if you were missing certain parts or even if certain things you wrote there I didn't think made sense, you got full credit as long as you did it. Homework 3, you got a bunch of points already. Now I have to go back and give you more points once I scrutinize it more specifically. I hope you understand that system now. You're getting used to it, hopefully. So let's just crank on, as someone has said in the direct chat. I think, for better or for worse, we're still in the middle of homework 1. So I'd like to, like crank through that sort of more quickly and start catching up with ourselves. And we won't assign another homework until I'm more caught up with you. But correct me if I'm wrong, and correct me if you can't hear me, whatever. I believe we are still in homework 1, number line And I'm going to say this too, and you tell me in the chat if this doesn't work for you at any moment, but because I'd like to make tracks, at least one person has said in the direct chat, we'd like to just move on with these solutions. And I totally agree. Therefore, at least for right now, while we're trying to catch up, I'm going to be giving like answers and help, but not full formal 5-step solutions. In other words, I'm going to, and then I'll do this from time to time. I'll go back and forth throughout the semesters, but I'm going to assume that right now you basically get the 5-step method. I'll see again when I scrutinize your homework 3 more carefully. But I'm going to assume that you understand that that's what we always expect from now on. But I'm not always going to walk through all the steps every time in class if I'm just trying to get to material. So stop me at any point if that's not clear. But today I'm going to get back to the questions of homework 1. I'm going to write down whatever work I think I need to explain or that you might have missed or whatever, but I'm not going to do all the explicit steps. So these are not like if you put what I'm going to put down here, if you put it on an exam, it would not be full credit if that makes sense. Okay. That and maybe someone should confirm in the chat if that makes sense. But I think that said, we are on question. Stop me. I think we're on. Yeah, I think we're on question 4. I believe from t equals 0. So I'm not even redrawing the diagram again right now. I'm assuming you have it in front of you somewhere. Makes sense to me. Okay, thank you. I appreciate it, Paulina and Mohammed. Okay, cool. Okay, and I think I'm on question 4 if we're around question 4. So question 4 is from t equals 0 to t equals 8. What is the average velocity of the instructor, right? Again, just stop me if I'm in the wrong place or if I'm doing something wrong. But I think, and so from here on in, I'm going to use notation, right? I think the question is from t equals 0 to t equals 8. What is the average velocity? And if I didn't make this clear last time, I think I did, but just note, I'm saying to you guys now, note, like side note, as like physics teaching instruction, from now on, V means velocity. Now there's different types of velocity, okay? But the type that we're defining, in fact, let me be really, really clear. There's different types of velocity, and physics has a lot to do with these different types of velocity. But the type that we're defining here is average velocity, right? And to make notation clear before I go any further, from now on, if we ever put a line over a variable, a symbol, then what we mean is the average value of that symbol, right? So line over something from now on means average. And I may have also mentioned in the last class, and you may want to write this down. Well, no, I'm going to write it down. Okay, just to be super clear, super explicit, big difference. And anytime I use a squiggle like that, I mean it as like some generic variable. You know, it could be X, could be Y, could be V, could be A for acceleration, could be F for force, whatever. But whatever your variable is, the big difference between just seeing that variable written as it is versus seeing it with a bar over on the top is when the bar is on the top, it means the average value. And what average value means is the representative value. When you have a variable that has a bar over it, so like here, our example is velocity. When we say average velocity, what we very specifically mean is we're not talking about the velocity at a point in space and time, but rather we're looking at an interval or a segment or a region between 2 points in space and time. We're looking at a region between 2 points in space and time during which it's highly possible, it's like very conceivable that the value of velocity is varying, is changing all the time. Maybe in a pattern, maybe not, maybe continuously, maybe not. But like once we are talking about averages, what we're saying to ourselves is we're looking at an interval between 2 points in space and time. We're acknowledging the strong possibility that there might be all kinds of different values of the variable between those 2 points. And by saying average, we're picking or measuring or determining or calculating the one value that we think best represents the whole. The one value that if we wanted to sort of pretend that nothing ever changed in the whole interval, then that would be the best value to use to pretend that nothing ever changed. I want to say that strongly, and I will move on. I'll go to the thing, but because that's what average means to me as a mathematician or a physicist, it means the one value that best represents a whole bunch of changing values. How you compute that one, there's different methods, as you know. Sometimes there's something called a mean, like or an arithmetic mean. Sometimes there's a mode. Sometimes there's a median. There's a geometric mean. But that's a whole different issue. That's like how, like mathematically, how you arrive at the best way to represent a whole bunch of changes. All we're saying here is if you had one value that you somehow came up with that represented a whole bunch of changes, then that's what we mean by average. So back to the problem, back to the homework, or back to the physics. Then, so the definition of average, so the definition of V bar is average velocity. How do we in physics compute average velocity? We say that the definition of average velocity is the total displacement between 2 points in space divided by the total duration between 2 points in time, right? Again, I just want to emphasize here that all average velocity is the one rate that something went when it went from here and now to then and there, the one rate of travel that we ascribe to it is the simplest possible ratio of just the space chunk to the time chunk, right? This is our definition. And because the way we use notation, so I want you to see it's like balance. It's like space divided by time. Like we're not treating either one as any more special than the other. But then because time is the independent variable, T naught always does equal 0. So we end up writing it always shorthand like this, right? And what I'm really trying to emphasize here, and then I will go on, I promise. Right, so this is the universal definition of average velocity. And note it's triple equal sign, right? It's a GDP. It's often a step 3 in lots and lots of physics problems. By saying that is the definition, what we're saying is if this is ever right, it's always right. It might not always seem helpful, but it's never wrong. And what it really is not saying, what we're literally saying here, I'm trying to like really, we're not saying that average velocity is add up all 3 velocities and divide by 3 or something like that. That's not what we're saying. We're just saying it's how far you got and how much time you took. End of story. So, okay. So, and those of you who did homework 3 may have seen by the end of homework 3 why this really matters. But so here I'm just, it's got a plug and chug, right? So everything I just wrote was technically about like a step 3 GDP. Now, if I were to do step 4, I would say, okay, here, the total displacement we already figured out was -9 feet. the total time, like the total time from the beginning was 8 seconds, right? So here, average velocity equals -9 feet per 8 seconds. You can leave it like that if you want here, or you could say something like -1.125 feet per second. Either one's fine. And just notice okay, just notice that velocity is a vector quantity, just like speed. So velocity could be negative or positive. This average velocity is negative. That is not a contradiction. It doesn't mean anybody's going backward in time or something like that. It's like not Back to the Future or something like that. Also, though, it doesn't mean, and please note this, it doesn't mean anybody's slowing down. We're not talking about that. This is an average. I have no idea whether he's slowing down or speeding up. In fact, no, I do, because I was told in the problem he's maintaining a constant velocity or a constant speed for each one of these intervals. So he's not speeding up or slowing down. The negative sign, which is totally okay, just means on average during this interval, the instructor is traveling in the negative direction, which in this case means left or perhaps west or something, right? So velocities can be negative. What you have in your car, if you have a car, if you've ever been in a car, you notice you have a speedometer in your car. It just has a bunch of numbers on it. The car only tells you whether you go 0 miles an hour or 10 miles an hour, or 30 or 40, whatever. It just gives you a number. It's telling you your speed. It doesn't care at all what direction you're going in. But if you hooked up your speedometer to your GPS, or if you had a compass in the car or something, which you certainly could now in modern technology, right? Like if the speedometer were to say like 30, I mean, if that hookup were to say, you're going 30 miles an hour north right now, Yaverbam, and then I turn around the car and then it said 30 miles an hour south, or if it said positive 30, and then when I turned it around, it said negative 30, then that would be a velocity-o-meter, right? But until the direct, and that's all it would mean. It wouldn't mean, you get it. So, okay, so that's the answer to this one. That's the answer to this one. Okay, again, I'm only talking fast to catch up with myself, but if you have any issue with anything I'm saying, please stop me, and then at least I'll feel like I'm doing something. But other than that, until you do, or unless you do, I'm going to go on because I think Claudia is totally cool. I think Pauline is totally cool. I think Maria is totally cool. I think Josephine is totally cool. Okay. And yes, okay. And I mean totally cool in more ways than one. Okay. So I'm going to go to the next one. Question 5, which of course now I'm just going to bring up the sheet. Bear with me for a second. Unless someone wants to quickly put in the chat what the, oh my God, why? Oh my, I can't do that. Sorry. Okay. You may want to bear with me for a second. What the God? Sorry. What just happened? Okay. Sorry. This seems to be quite a month. If someone could just put in the chat, remind me what the next things are, or maybe you already did. He probably already did. Hold on. Could someone actually? Could someone put in the chat what the? I'm a little bit losing my mind here, I think, and I'm not quite sure why. But if you could just, or maybe I can remember. Can you tell me the next?
The next question.
Yes, please. Yes, thank you, Pauline. Thank you.
It says, what is the instructor's average speed for the first 5 seconds of the journey?
Oh, okay. Right, great. All right, thank you. Yes. Okay. So now, again, and again, just to remind everybody, whenever we're in words like speed or distance, when we're in the scalar quantities, they're meant as practice, they're meant to distinguish the concepts, they're meant to help you as building blocks toward the real things, which are vector questions. And I'm only saying that to say, whenever it says something about speed or distance, I tend to keep it in English. I mean, even my work, because we don't, the equations don't, the notation doesn't really apply to those. So I'm just going to do what Paulina just said in English. So it said from t equals 0 to t equals 5, what is average speed? Right. So average speed, and hopefully you can see, I'm leaving out the diagrams, but you could see, I just did step 2. Now I'm doing step 3. I'm not labeling it right now. I'm trying to move faster, but average speed by definition is distance over time. Again, I'm sort of using that writing it in English. The now from t equals 0 to t equals 5, I believe that's the distance, correct me if I'm wrong, but I believe this is where he goes from 4 to -2, and then goes back from -2 to 4. Stop me if I'm wrong, but I believe that total distance is 12 feet. Right? It's like 6 plus the app. Maybe I'll even say this if you like. Where am I getting 12? I'm saying 6 plus the absolute value of 6. If that may, oh, I'm sorry, 6 plus the absolute value of -6, if that makes sense. And it's in 5 seconds, just because that's what the question says in that first 5 seconds. So I believe the answer to this is 12 feet over 5 seconds, which you can leave that way for a question like this if you want, or if you don't like that, which I understand, you could say 2.4 feet per second. Either one, but I think that's the answer to that. Again, please stop me if, or are we, I know we're totally bored, but are we clear? Are we together here? Like, are we on the same page? Like, yes. Okay, thank you, Paulina.
Professor,
Okay.
it's the same as the one before him, because in part 1, number 5 is the speed, which is equal to distance over time, which is 12 over 5, which is also equal to 2.4 seconds.
Wait, okay, so first of all, thank you, Shawnee, for thank you for participating, and thank you for using your voice and everything. I think that was Shawnee. Okay, and is on mine is like a little bit hard to hear, but I think I did hear what you said. So I'm agreeing with you. If I understand what you're saying, I agree with you that we're doing the exact same method. This is a good example where we're doing the exact same method. Specifically, we're using the exact same GDP, like the exact same step 3 as we did in an earlier question, yes. But the only things that are different is like the facts of what we're being asked. Like this time, earlier in the homework, we were asked, what's the average for the whole thing, for the whole 8 seconds? And here we're just looking at a specific chunk, and we're being asked, like, what's the average for just that 5-second chunk? So I'm going to say one more thing. I'm going to check with you that this is what you're asking. But if this is what you're asking about, I think it's actually a really good question. So if you were doing out your homework, the only everything would be identical for step 1, step 2, and step 3. Step 4, particular application and work, is where these two would differ, because just the details of the number details of what we're being asked would differ from the earlier question to this one. So then the answers would differ, because I think in the earlier question, we were asked, what's the average speed for the whole thing? And I think that answer was 21 feet over 8, whereas here it's 12 feet over 5. And first of all, am I even addressing your question? Is that what you're asking?
No, I was asking because for number 5, I had gotten speed equals distance over time, which is 12 over 5, which is 2.4 seconds, which is the same answer as it is here, but I got that for part 1, number 5.
Yes, isn't this? Oh, I believe this is. Sorry, yes. I mean, I think I agree with you. I think I am thinking that I'm doing part 1, number 5. Am I not? Yeah, that's what I think.
Oh, you still on part 1? I thought we were on part 2. I'm sorry.
Oh, no, I'm sorry. And maybe you're right. Maybe I forgot. I think I'm still on part 1. You could stop me. Anybody could tell me if I already did all this. Please let me know. I don't want to waste anybody's time. I think this is up where we are. Well, it is. Okay. I'm looking at Paulina's thing in the chat. Okay. See, I think that, but yeah, well, at least what I'm doing right now is still part one. And maybe I've lost, clearly I have lost my mind in some way. But yes, I think I'm still on part one. So yes, good point. Okay.
Okay, so then we're completely fine. We got the same exact answer. Never mind.
Awesome. Oh, okay,
I
perfect.
just got confused because I thought we were on part two.
Oh, sorry. Gotcha. Okay, cool. Thanks. And it would be helpful to you guys if I were a functional human being right now and was actually, if I had this thing up, I don't know what is my, well, okay, anyway. All right. Yes, so good. Okay. So that's question 5 of part 1. Now we're on question 6. Okay, so this is still part. Okay. Okay. So then I'm going to assume, you're going to correct me if I'm wrong. I'm going to assume that the next question is from t equals to t equals 5, what's the average velocity? Like there's a pattern here, right? Like now, so it just asked you average speed to sort of warm you up for this interval. Now I assume, or I believe I remember that what in the name that we're now asking for the average velocity. So it's almost like each
Yes.
time we're sort of like, oh yeah, okay, cool. So, and kind of the pattern of the sheet too. Again, I know I want to move on as much as you guys do, but kind of one of the underlying things of the sheet that it's trying to show y'all, and even train of thought in a way was trying to show, is trying to show you, like, okay, yeah, let me pause for a second and say this. I know there are some of you who are definitely being driven crazy by the fact that we don't have a lot of equations yet and stuff. I totally respect that. But actually, part of what we're trying to show you is that all the equations that you get in physics or that you think of as physics, we want you to know that these equations are not formulas. They're not like just pulled out of a recipe book or like the back of a textbook and then we all memorize them and do stuff. That the truth is all the equations come from concepts that like can totally be explained and expressed and understood in English. Like we kind of, and you'll notice that the first equations we're getting are literally definitions that could first be expressed in English. And then we make up symbols for them just to make it shorter to write down. But we're kind of trying to rebuild the math here to show you all that the math is not some left turn or some like, okay, let's just memorize this crap because like the teacher said so. Like, so the pattern here, anyway, I think you hear that, but I just always want to reinforce that because when the math gets really mathy, which it will, and particularly in physics 204, it gets super mathy, and then sometimes it starts losing people. The trick is to always remember that all the math is all comes back to something that we can think through in English. It's never supposed to be like a leap from nowhere. So the pattern here is like we ask a question about average speed in English, we kind of do it, see what it makes sense, and then we get the more strict, precise version in average velocity, like I'm going to do here. So the average velocity. Okay, so I believe, and I think someone just confirmed the question. So now we're asking the same question, but we're asking about average velocity. So now here, if I'm writing out my step 4 here, well, okay, sorry. So step 3, right? Step 3, the definition of average velocity, like we said before, is displacement over time. Okay, so that's my step 3. But now here, if I do my step 4, if I'm looking at this problem here, x, like x naught, where the dude starts at t equals 0, at the beginning of this whole thing, where he starts is the position positive 4 feet, right? Where he, now this, okay, where he ends, what I'm, right? So x naught, initial position when time equals 0 is, I believe, plus 4 feet, right? Final position, x, means now, let's be careful, final position for this interval that I am investigating, that I'm being asked about. Again, I'm imagining probably a lot of you got this right. But let me just slow down and point out what you must have been thinking. If you got this right, you were thinking that the final position to like pay attention to here for this is again positive 4 feet, right? Because at the end of 5, right? Because he starts at positive 4, he goes all the way to -2, like the directions say, the instructions say. That takes 3 seconds or 2 seconds or something. And then the remaining number of seconds, he comes back to positive 4. I'm just trying to express right now, notice, if I say that the final position is positive 4, which I am, I mean, it's correct. I'm saying the final position for this little specific thing I'm looking at. It's not the final position for the whole freaking experiment, right? And that's really important to recognize. Again, this is kind of what train of thought is about in a way, is that like you physics is all about perspective. At any given moment, someone's asking you a question, you decide when to stop your stopwatch. You decide when to stop your stopwatch. Like physics is just going on. And you enter the scene and you start your timer at a moment that you want to start collecting data, and then you stop your timer at a moment that you stop collecting data, and then those two things become initial and final value for that context, right? It doesn't mean final for the whole lab or the whole problem sheet or the whole universe, right? So I just hope, and when it's easy, but then when things get hard, people forget that. So anyway, okay. So the initial, and stop me if I'm just trying to pull something up. I can't, if there's something in the chat, I'll see it in 1 second. So it seems to me on the next page, then for this 5-second interval, here, step 4, average velocity equals a displacement of 0 feet, right, over a time of 5 seconds, right? So here, the average velocity is 0 feet per second. And let's pause on that for a second. In fact, let me like really pause on that for a second. Okay, good. Finally, my life is okay. Oh, you thought it was physics class? I'm sorry, I thought it was group therapy. Okay, no, just kidding. I'm just finally being able to pull up the sheet while I do this. So I want to, but again, I'm hoping, believing maybe a lot of you got this right. Maybe you don't think you need to hear too much about it, but some people did not get this right. And the key point is the average speed was some high number, like 2.4 feet per second. Average velocity for the same experiment, like we're taking two different measurements on the same phenomenon. The average velocity measurement was 0, even though the guy is clearly moving like most of the time. Almost all of the time. He's moving that way, then he's moving that way. But on average, we're saying he ain't moving at all. On average. How can that be? Because on average, he got nowhere, right? He was not displaced at all. I don't care how long he took 5 seconds to wind up nowhere. So on average, he was at rest. Do you see, right? Okay. And if you don't, I mean, definitely ask me questions if you don't like, but that is surprising to some people. Sometimes I'm just looking in the chat. Oh, okay. I'm looking in the chat. What do you have in chat? Oh, sorry. Oh, I'm glad. Oh, okay, wait. I'm glad people are putting things in the chat. Thank you. Wait. Oh, I lost a lot of chat. I'm glad you're all in the chat. Okay, I see it now. 1 second. We're on part 1, space and time. 0, yeah, 0 over 5 seconds. Yeah. Okay. Oh, yeah. So wait. I think this address, and thank you for all helping each other, and you should all submit this for points. But on Shawnee's thing of, unless it's already resolved, I'm just saying, where did you get the 0 from? If you agree with the 0, if you think about what you had to do in your mind to get that 0, technically what you're saying is he started, like you're saying he didn't get anywhere because his starting and his ending positions were the same. But what were they? They were +4. Like that's where he was, both. And yeah, even if they had been +3 minus +3, it would still be 0. But the only way you knew that he didn't get anywhere is if somehow you read the problem and read the parts where it said, oh, he starts at, like if you break down your thought process, somewhere you had to acknowledge, oh, okay, he started here at +4. Oh, he ended here at +4. So he got nowhere. Do you see what I'm, let me see, look in the chat. Oh, you got, okay. Great, fine. Great. And thank you for helping each other. Okay, so that's that one. Okay, we're almost like, oh, makes it cool. I appreciate the little like make sense shout outs too. You can see I really need them. All right, all of you. I mean, I appreciate the fact that you haven't like run screaming yet, any of you. Actually, how would I know if you had? I can barely hear anything. Okay. All right, so that was all right, so now we're done with part 1 finally. Okay, we're finally almost having a class. Okay, part 2. We should almost change color and excitement. We should put a Bitmoji in. Okay. So this is part 1, question 1. Again, all right. So now, like, what are we getting at here? We're just shifting gears slightly and saying, like, time is always the independent variable, but that doesn't mean we have to make all measurements in, like, we're taking it up a level and saying, now you start looking at where he is. I don't know what we're doing. Anyway, the question is the distance. I'm just going to cut to the chase. The distance is, well, let me put it this way. I think what I'm getting at for all these is, if we have a clear definition of displacement, which we now do, we have a clear like equation, precise definition, displacement equals final position minus initial position, right? Like I am definitely saying that. if I ever hear the word displacement, I mean x minus x naught. Well, then from here on, I can really say that what distance is the absolute value of displacement. I mean, that's right? Distance is the magnitude of displacement for any one given interval, for a given interval. I mean, it gets trickier when you add up a bunch of intervals, but for a given interval, that's the case. So here, the distance is the absolute value of 4 minus 2, right? Final position minus initial position, but the absolute value. So that would be, so it's the absolute value of 6, which is 6 feet. So I think that's the answer to that one. Right? Okay, I'll probably make it more hard, right? So the distance is 6. And then what's the displacement? Well, the displacement's the same thing. Why? Because in this case, he happens to be traveling in the positive direction. So the absolute value didn't make any difference, if that makes sense. So the displacement equals x minus x naught with no absolute value. But here, the displacement equals 4 minus 2, which equals 6 feet. Same thing. Stop me if, right, so that's number 3. Okay, 3. All right, so 3, we want average speed. We're just building up these concepts again. Average speed equals distance over time. So here, so we have the facts. We just got the facts for this. Average speed equals the distance for this interval that we're already talking about. So 6. And the time, well, it tells you, right, in the first question, we're talking, this whole thing takes 2 seconds, right? So it's 6 divided by 2, 6 feet divided by 2 seconds. So average speed equals 3 feet per second, right? I think that's the answer. So 3, positive 3. Of course, if it's average speed, it would have to be a positive number. Then 4, what's the average velocity? I'm going to cut to the chase again, because I mean, in a way, I don't even know why I asked this years ago. I mean, maybe this would have been a more clever question if you happened to be going left. If you were going left for all of these questions, then all the answers would differ by a minus sign, if that makes any sense. But that's not what the questions say. So the average velocity, I'll cut to the chase. Stop me if you have any questions. The average velocity is 3 feet per second. That's for 4. So as I mentioned before, I'm basically just giving answers at this point. Okay, now it gets a little, all right. Now the average speed during the final 3 seconds of the journey. So again, I'm going to go to the next page here. Again, I'm. Please stop me if this is too fast for anybody. 5. What's the average speed? From t equals 5 to t equals 8, right? That's what we're talking about now. Okay, so step 3, I mean, no matter what, average speed equals, by definition, distance over time. The time is given to us straight in the question, but the distance is the thing we have to think about for a minute. Like, what is the distance in the final 3 seconds of this journey? Well, I think in the final 3 seconds of the journey, remember, distance, I'm now going to say distance is the absolute value of displacement, as long as you're talking about one interval. So in that last 3 seconds, I believe he goes from positive 4 to negative 5, right? And notice I'm always writing it backwards. Like, he goes in time, he goes from positive 4 to negative 5. So I subtract in the reverse order to see how far, right? So I go negative, I do final minus initial. So the distance equals the absolute value of negative 9 feet. The distance equals the absolute value of negative 9 feet. So that's 9 feet. So it does seem to me that the average speed for the whole last thing is 9 feet divided by 3 seconds. So this is getting sort of redundant, but I think I'm not changing it. I'm just making it slightly more legible. 9 feet 3 seconds. So we get 3 feet per second is the average speed for that question 5. I'm just looking at the chat. I think we're good. We seem to be good. Okay. Oh wow. By the way, oh, that's awesome that Muhammad like drew. Sorry, I'm just seeing now that and not to be, I'm not going to distract myself, but it's great. All of you are helping each other a minute ago in the chat. And but I do want to say, remember, Muhammad put a picture in there. There's definitely a portal specifically for that. I think it's called Worth 1,000 Words. The mere fact that someone put in a diagram of some of their work into the chat, like definitely highly encouraged, highly appreciated. There's points for that. Okay, so thank you, Muhammad. Okay, so that's question 5. Now question 6. Oh, oh, okay. Sorry if the explanation was confusing. Sorry. Okay, sure. All right. Now, all right, to cut to the chase, we now want the average velocity. We know that's displacement over time. We just got all those facts. Like the displacement for the last 3 seconds was 9 feet. We just got that from above. The time was 3 seconds. So the average velocity for the last 3 seconds is -3 feet per second. Right now, again, a lot of people. Part of the reason I'm going a little fast, besides the fact I think you all want me to, is that a lot of people got a lot of these correct. Right now, we're up to the last 2 questions. Thank goodness. Now here it does get interesting for a lot of people. I'm going to slow down slightly here because I do think people did very different things here. And I'll try to explain it clearly. You might have better, you might share your own explanations. Maybe they'll be more helpful to you, but you should definitely not feel ashamed to stop and ask me in the middle, directly or publicly. All right, so I'm going to go to the next page. So we're talking part 3, question 1. This now, and I'm going to, again, you have the diagram in front of you. I'll even say see diagram above. So that's my step 1. And then question 1 is at t equals 7. Where is the instructor? I.e., what is x? Right? So that's my step 2. That's the question. So now GDP, okay, this is interesting. We want to know where the guy is at the 7th second. There's no formula for that, like not explicitly. I think I don't, there's no formulas for anything really, but is there even a definition for that, for position? Well, no, but this is where we start doing physics a little bit here. Like the only equation we have so far, really, that's why I keep writing it on the front page of every class lesson so far. The only equation we have so far really is the definition of average velocity. Average velocity is defined to be total displacement per total time. So that's all we've got. Because it's a definition, if this were an exam right now, even if I were stuck, I would literally write that down because it's true. It's definitely true. And it also seems vaguely possibly related to the topic, right? But honestly, if this were an exam right now, even if even if you don't, some of you did get this question, some of you got stuck on this question, some of you did it but got it wrong. That's all fine. But let's assume for the minute that this is a question that does require a little bit more thinking, that maybe this is the first question in the sheet for some of us where we look at it, maybe we can do it, maybe we can't, but we don't right away necessarily see an answer, or we don't even right away necessarily see how we're going to do it. This is where the whole GDP thing really starts to become very important. The harder a question is, because I'm going to tell you right now, a tendency that people have when they get nervous on exams or in science, when people get nervous, what they tend to do unconsciously, and you might even want to write this down. I think this is like a really important recognition that I came to years ago. When we get nervous, we tend to first try to write something down that's relevant, and then we try to make it true. I'm not saying we consciously do that, and I'm definitely not saying that we should do that. But I'm saying a tendency that we want to fight when we're nervous about an exam question is what we tend to do is, well, let me write down something that seems like related. Let me write down what I think the professor's getting at. Let me write down like what I think I was supposed to study. And then let me do some like algebra to get it to become a right answer or something. It's totally a reasonable human thing to do that, but it's actually what gets us into trouble. So what I'm saying, if you want to write this down, and it's actually in one of the tools that says like what to do when you don't know what to do, don't like or try to fight the unconscious tendency to write something relevant and then make it true. Instead, when you don't know what to do, which is some of us for this question, when you don't know what to do, write down something true and then try to make it relevant. That's the trick. Write something that's just freaking true, because at worst, you're going to get points for that, even if you don't know what to do with it. Don't assume that you need to know what you're doing in order to do stuff. Start doing stuff. And so I'm writing down the only truth I have in this class so far. I'm writing down the only equation I know is definitely true, and it's like vaguely on the topic. Average velocity equals change in position over time, or displacement over time. But now, since what I'm looking for is X, okay, now I'm going to algebraically rearrange it. I'm going to say something like this. Well, and I know the algebra, you can all do this. Like, I don't think anybody, but like I can do that, right? I can multiply both sides by t. And why would I? Because the thing that the question's asking for is like a X, not a V value, right? And notice also, this is a trick again. And those of you who did not get this right, you definitely want to listen to me, of course. But those of you who got this right, I'm encouraging you to listen to me anyway, because it'll be easier for you to hear what I'm saying right now if you are not worried about the question. For the future, I want you to notice that you might have gotten it right, but what you might have done is started plugging in numbers and then rearranging. My next piece of advice to you, as physics is getting harder,
I can't hear you. Professor, can you hear us? I don't think he can hear us. Hello? He's still talking. Hello? Yeah, he's still going. He can't hear us. He's not even looking at the screen.
but use the easier, and if you don't, that's also totally fine. But if you do think these questions are manageable right now, use them as an opportunity to start practicing harder techniques. And one of them is
Professor,
yeah.
we missed like the last like 30 seconds of you talking. We've been trying to get your attention in the chat.
Oh God.
That's
Okay.
why so many people have their hand raised.
Oh God. I was looking at the sheet. I can't even see. I'm so sorry. All right. Thank you. All right. Thank you. Wait. Oh my
We
God.
just couldn't hear you.
I'm so sorry. I don't know what's going. This is really. I'm so sorry. I know this is so frustrating. It's very frustrating for me too. I don't know what's going on with the technology. Okay. And I didn't see you all, and you did the right thing. I didn't see you all because, well, partly I was like ranting, in my own head, but also because I was looking at the screen, but I was looking at the sheet, the question sheet instead of. All right. All right. Sorry. So where did you lose? And I was probably saying too much anyway. But where did you lose me? What was the last thing you heard me say? Or wait, can you hear me?
You were explaining to us that right before like writing down the re-equation for the x's in the equation, that's the last part that you left off on.
All right. So all right. Well, thank you again for being so patient and considerate. I went off on a big rant because but I'll just summarize. The bottom line is I want to encourage you all to start getting in the habit of rearranging equations first and then plugging in the numbers at the end. Like I'm going to do this now. And this is another one of these beats where I'm recognizing that some of you got this wrong, so I'm explaining it. But some of you might have gotten it right, but might have done it a different way. And there's always this question like, okay, I got the same answer as you, Professor, but I did it a different way. Is that okay? One thing that a lot of you probably did, maybe, if you got it right, is you may have done something like what I'm about to do, but you might have plugged in the numbers right away and sort of rearranged things. So you didn't even, and I want to just say to everybody, would that be acceptable on an exam? If you just plugged in the numbers first and then started rearranging like the algebra, would you get full credit on an exam? Sure, yes, you would. But I am telling you as a hint or as a technique that right now would be a good time to start developing the habit of trying it my way, of always try to rearrange the algebra first and postpone, do all the algebra first. This is why we do GDP and then PAW. You set up your equations, then do as much as you can to rearrange them to make them to how you need them for the purpose. And then at the last minute, plug in the numbers. And all of you are going to find at some point that you're not going to want to do that. I get it. Like it seems easier now to go the other way because we feel more comfortable with numbers than algebra, many of us. But I'm saying if you got this answer right at all, if you got this right, that means you're okay with the physics right now. So this is a good example of where you want to start practicing the technique that I'm telling you is in long-term better for harder physics of try to postpone numbers as long as you can in your process. If for no other reason that just in case any of your numbers are wrong or any of your calculator computations are wrong, you'll lose a lot less points that way. But anyway, so that's what I was ranting about. But sorry, you can hear me now though, right? You can hear me now? Or yes. Okay, thank you, Claudia. And I'm looking at you now. Okay, so I'm just going to keep going. So I did the algebra. I'm rearranging this equation to say this, right? And it's literally asking for what is x. So I'm rearranging it one more beat like this. Now, notice also part of the advantage of doing it this way, which you may or may not have done, is like I have an equation here now. Like I have an equation, x equals average v times t plus x naught. That's literally a physics equation. You could put it in the back of a textbook, but I'm encouraging you to don't do that. Like I'm not saying you now have to memorize two different equations in physics. I'm saying we have one definition in physics that we can now manipulate however we want, whenever we want. Anything that's true about it is from now on true. We don't want a whole list of things to memorize, but everything we do in physics really is creating and manipulating equations. It's because they're all true. Anyway, so now we have this. So don't memorize it. Don't start your next problem with it, but just realize this is a version now of a truth that we already had. So now, so this is all still part of step 4 that I'm doing. Now I'm going to plug in, or I'm just going to rewrite it again. So I have x equals v. And here, now I'm going to plug in the values, right? Whenever I say here, I mean, what are the numbers for this situation? Well, we're talking, okay, now let's be this is where a lot of people went wrong. This, I hope you hear, like, have a look if you can't hear me. Here, well, t is clearly, well, no, it's not clear, actually. I'm going to say t, sorry, well, okay, I'm saying here we are looking at the 7th second, right? So there might be a temptation to plug in 7 for t or something like that. There might. And even more, but don't do that. There might be a further temptation that a lot of people did of plugging in for average velocity. A lot of people plugged in something like -9/8 feet per second, like negative 1 point. Like a lot of people for average v plugged in their average v from the beginning of the whole sheet. Don't do that. What I want to say here is kind of the reason that from part 1 to part 2, they kind of asked the same questions over and over, but they asked about averages for different intervals of this whole experiment is they're kind of trying to remind you or drum in that the whole thing about an average is that it applies to a given interval. Averages come up when values are changing. So averages change, right? Like if you take 3 exams in a course, your first exam is a 95, right now, coming out of that exam, your average is a 95, right? Then on the next exam, if you get an 85, now your average is a 90. Your average wasn't a 90 like 2 weeks ago, but now it is, right? Like averages change over time as the data changes over time. So if we're going to say that the beginning and the end of any experiment is like whatever's up to us, the researcher, if that's what we're also trying to drum in with all of this, that the 0 point when you start your stopwatch is a matter of choice, but you have to make a choice, and you want it to be a convenient choice. What I'm going to say right now is we should take all our data for this, or all our values, if you like, all our values from the very last constant speed interval or segment, the very last segment that goes from t equals 5 to t equals 8. Let me say this clearly a different way. I'm saying, remember at the beginning of the problem, like first the guy goes like this, then he goes like this, and then he goes like that. In each one of those segments, he has a different constant speed, which ultimately means for each of those segments, he has a different average speed. So the average speed that you would use for one would not apply to another, and the average speed you would use for one for the whole thing would not apply to any of the individuals. But each one, everything is constant. So this 7th second that we're looking at here, we want to focus our attention. We want to like zoom in and just look at whatever interval of the whole experiment contains that 7th second, whatever interval we can isolate for which all values are as constant as can be, right? So I'm saying two things. What am I? We're looking at the 3rd segment. Like I'm saying, zoom in our minds, zoom in on final segment, the 3rd segment of the motion. And during that, so I'm basically saying, so I'm really saying that at t equals 5, that's when we're starting our stopwatch in our mind now. What used to be called t equals 5 is now known as t equals 0, in effect. So for this context, the average velocity is the one that we were asked to solve for in one of the later questions in part 2. Like we were asked to get, in question 6V, we'll see part 2, question 6. The average velocity during the final the final 3 seconds of the journey, the average velocity we said was -3 feet per second, right? So that's the average I'm going to use here. Again, I know I'm over talking as usual, but this is honestly, the people that did get this one wrong, this is what they got wrong, most of them. Like for average velocity here, we're going to plug in -3. And what are we going to plug in for time? Maybe this is confusing to people, but I'm not going to plug in 7. I'm going to plug in effect 2. Why 2? Because I'm starting my clock in my mind at t equals 5. So from 5 to 6, that's 1 second. From t equals 6 to t equals 7, that's another second. Right? I'm basically, well, I don't know how else to phrase it, but start our stopwatch. I'm saying start our stopwatch at t equals 5. Then that would mean that v bar equals -3 feet per second, t equals 2 seconds, and x naught, like that means where is the instructor at the beginning of this segment that I'm looking at, right? And where I am at this where I am at the beginning of this segment at the 5th second, I believe, is +4 feet, right? Yeah, I mean, which also does happen to be the beginning of the whole thing. So then I'm going to plug into this equation that I just made up, right? I just derived. I'm going to plug in and say, fine, x equals, now again, I know a lot of you did this in a different way and still got the right answer. That is fine, but I also want you to write down my way for future. I'm saying something like this, -3 feet per second times 2 seconds plus 4 feet. And so we get -6 feet, like the seconds cancel out. We get -6 feet plus 4 feet. I'll just complete it right here. So I think the answer to this is -2 feet. Let me be very clear about that. I think if we can understand this, we could definitely understand the next one. But I do think this is the hardest question on the sheet so far. I think the answer, oh wait, I'll go back to the Zoom. Sorry. Okay, wait. Okay. I think the answer is x equals -2 feet, number one. What does that mean in English? It means I think that at the 7th second of this whole journey, at the 7th second, where the instructor is at the -2 mark, like the -2 feet mark, right? I think that's something that I could not see in my head until I did this. Like that's, for example, that's a mark that was never mentioned in any instructions. It's not like an obvious place, right? But what I really think but I think it's the answer. And what I really think just happened in English, just to back up for a second, what we're really saying in English, and it's great if you could supplement any of this with English in your response, if this were homework or an exam. What we're really saying in English, if I'm just picturing it, is, okay, in that I'm just focusing my attention on the last 3 seconds. So he's at +4. And in the last 3 seconds, he's going to go all the way to -5. And it's going to take him 9 seconds. I mean, it's going to take him 3 seconds. So what we're saying is here he is at 4. For this journey, that all I'm looking at, this final journey, he's standing at the 4. He's moving this way to the left at 3 feet per second. Like that means every second he goes that way by 3 feet. So he's at the 4 mark at the beginning of this, at what we're calling t equals 5. But the homework wants to know, where is he going to be at t equals 7? So it wants to know, where is he going to be in 2 seconds? So he's standing at the 4, and every second he advances to the left by 3. So he's at the 4. In 1 second, he gets to the +1, like he goes left 3. He gets to the +1, and in the next second, he goes from the +1 to the -2. That's what we're saying in English, that every second, and that's what that equation that we just derived saying. It's saying, you want to know where he is? Well, just ask yourself where he started off, and then add to that whatever his velocity is times time. It's like saying distance equals rate times time, right? But it includes the fact that the velocity in this case is negative because he's going to the left. Okay, I know we have one more question to do, which we totally can do. I'm going to go. Okay, I'm looking at you guys now. Can you just give me, is that okay? Thumbs up. Like, are we okay on that? Okay, thank you, Maria. Thank you, Claudia. Okay, awesome. So the bad news is we won't do more than the sheet today. The good news is at least we'll be done with this sheet finally today. So let's do the very last question. And if you could follow that last one, I think you can follow so the last question. Okay, so the last question is, this is still part 3. Question 2. T equals 3 to t equals 7. What is average velocity? Okay, so what this really, so we know average velocity equals displacement over time, right? Now again, we know the time here. It's from t equals 3 to t equals 7. It's 4 seconds. The question is, what's x and x minus and x naught? Well, from t equals 3 to t equals 7. Well, at t equals 7, x equals what we just figured out, right? That was the point of that whole question. X equals -2 feet. And at t equals 3, the initial velocity, at t equals 3, we don't know offhand. Oh, yes, we do. At t equals 3, we know that he is also at the -2 foot mark. How do I know that? Because I scrolled up the sheet and I read the instructions. In the instructions of the sheet, in the setup, in the DFP, it says at the beginning of everything, he's at the +4 mark. But he moves from the 4 mark to the -2 foot mark in precisely 3 seconds. Like at the beginning of the whole experiment, it tells us that it takes the first 3 seconds of the whole experiment to get to the -2 foot mark. So we're actually told where, so we know. So therefore, in this segment that we're looking at, he starts at the -2, he does a bunch of stuff, ends up back at the -2. So this is like an earlier question we did. I don't care how much time it took him, since he ended up where he started, his average velocity for this entire thing is for this question, for this 4-second segment, this intermediary segment, is 0 feet per second. I think that's the answer to that one. And I think that's the end of the sheet. Okay. So I'm going to pause. So the good news is we have like 6 minutes left. So first of all, I'm just going to pause. Can you just look? Are there any questions about any of that? Honestly, we can breathe for a second. And I'm not going to start anything new now. You've all been very patient. I'm not going to start anything new. I might give a couple of answers if they help you. But are there any questions about any of that? Does that mean, can I get a thumbs up? Is it clear? Are we good with that? Thank you, Josephine. Thank you, Maria. Thank you, Paulina. Thank you, Josephine. Oh, thank you, Alexis. Oh, and I just heard a voice. Thank you. Was that
Shawnee.
okay? Oh, Sean. All right. Thank you, Shawnee. All right. Thank you, Mohammed. Thank you, Katie. Okay. Thank you all for being so. I'm always a spaz, but I'm usually a slightly more cheerful spaz. Just so you know, there's something in my soup this week. I don't know, or this month. But anyway, okay. That's that sheet. I don't want to, maybe the reward of being so flexible, maybe we'll even go a minute or two early. Like what I am going to, but don't go yet, just hang on. Like we have like 4, I think the best thing I can do is, first of all, of course, I'm going to stay till 1:30 if there's any questions at all, or private questions or what like that. If you're still, if you find homework 4 totally overwhelming because we still haven't gone up to homework 3, I totally understand that. And don't worry, we're not going to assign something new until I start actually talking about the acceleration things in homework 4, so you'll have time to go back and do them. Like, I get it. Again, I think if you're following this, I bet you, I will say that for many of you, if you just looked at the title of homework 4, or just looked at the title and looked at what we've done in class, you maybe reasonably be like, how can I possibly do this? We haven't even done. But if you look more carefully, if you just assume that you actually can, if you just go question by question, there's more explanation in there than you might realize, and more of it actually guides you through. And some of the answers are much easier than you might think if you just go step by step and see what you can do and what you can't, and view all of physics as like that. It's all about separating what you can do from what you can't. Anyway, but I understand if homework 4 starts giving people trouble, but just give it a shot anyway. Don't give up on it. Don't give up on yourself. I will say, so just 4 more minutes, for what it's worth, I think the answer to the Hill figure question, for what it's worth, just so you can feel like you're getting some money's worth here, on the Hill, so I'm on homework 3. I'm totally going to go over it. I'm especially going to go over the Hill figure problem and the Grandma Grimm problem. Like, those are the 2 tricky problems on the sheet. So I will go over them. I will tell you that I think the answer to the Hill figure problem, the second to last question on average speed sheet, I think the answer to that is 48 kilometers per hour, or whatever. I don't remember what the units are, but I think it's 48. I don't think it's 50. I don't think it's 60 or 40. I think it's 48. If that means you got it right, then you can, good, like, awesome. If it means you might want to rethink it, I can definitely guarantee you this: there's no information in that sheet that isn't covered by what we just did here. That I'm not saying it's easy, but there's no information that you're missing. Also, quick. Oh, so we too, and then I really will start with the train of thought. We are going to go over that too. As long as you did it and you made a thorough attempt, you got all the points, and you probably have a lot of check marks, which means I read. Whenever I put a check, that means I read what you said, and I like the legitimacy of what you said. It doesn't mean that I agree with everything everybody said on those sheets. And if I put a question mark or a bracket anywhere on it, what I'm probably saying there is, are you really sure that these 2 answers are consistent with each other? And sometimes I even wrote that. That's something to think about. Now we're going to talk. Okay, hang on for a second about the uploading, and I'll see if I can address that right now when everybody else goes. But we are going to talk about train of thought. It won't get lost in the shuffle. But I would think but don't assume that just because I put check marks, that means case closed. What's the real purpose of it is to get us to really start seeing how velocity is really a relationship between 2 objects, not a property of one object. That's like the next thing we really have to see about it, but we will get there. I'm going to shut up now. You've been very patient. You can go and have a nice 2 days. And don't just do homework for, but don't stress it. But anybody need to stay and ask a question, please do, including about uploading. Thank you. Have a good day. Thank you. I'm going to stop the. Thank you very much. Okay, I'm going to stop the recording.